Hello students, I am solving one more problem from IIT-JAM 2020 question. So this is question number 55. So in this question, they have given you a AC circuit, okay? And they have specified the value of R and C also. So R is particularly given as 100 kilo ohm, okay? And your C is given as 10 picofarad. And they say that the phase difference between V input and V output, okay, is 90-degree. Okay, so you have been given phase difference is given. So phase difference is 90-degree, okay, between V input and V output. Okay. So now they're asking what is the frequency? Okay, what is the frequency what is the frequency at which this phase difference is 90-degree? So basically you need to calculate the phase difference between V output and V input, okay? And then that you have to equate it by this phase difference, and that will give you the particular frequency at which this is 90-degree, okay? So let us calculate the phase difference first between V output and V input for given circuit. So say I want to find V output, okay? So V output will be what? V output will be nothing. This is defined as VB minus VA. Okay, so your V output is given by VB minus VA. Okay, now I want to find VB. So VB is what? VB is simply, if I see this circuit, this whole branch is parallel to V input. That is the total voltage drop, okay, across this branch is V input, okay, and I want to find this point voltage at this point, that is the voltage across this branch R, okay. So I can apply voltage divider rule and I can write VB is just R upon R XC. XC is the reactance of capacitor into V input, okay. Similarly, if I want to write VA, so VA will be what? The voltage across this capacitor, okay, at this point the voltage is VA, at this point the voltage is VB, okay. So VA is this one, XC upon R plus XC into V input, okay. Now let me calculate the V output. So V output will be your R upon R plus XC into V input, okay, minus XC upon R plus XC into V input, okay. So this will be equal to your, if I take V input common and then this factor common, so this will give you R minus XC upon R plus XC into V input, okay. Now I know that my XC is what? XC is 1 by j omega C, okay, and this I can write as a V output upon V input, okay, and I put the value of this one. This will give me j omega CR minus 1, and this will give me j omega CR plus 1, okay. Now this is a complex number. I can write this complex number, okay. This is the Z plus X plus iota Y type complex number, okay, and I can write this one as a magnitude, okay, R e power iota theta, okay, where R is the magnitude which is equal to X square plus Y square, and iota or J is the theta is the phase is given by tan inverse Y by X, okay. So let me write this in the form of phase. So if I write in the phase, so this will be, this numerator will be what? Magnitude will be what? 1 plus omega square C square R square. Similarly, the magnitude of denominator will be also 1 plus omega square C square R square. Let me call the phase of this one is iota theta 1 and phase of this one is iota theta 2, okay. Now what is the theta 1? Theta 1 is simply tan inverse Y by X, okay. So your X is minus, so this will be minus tan inverse Y is your omega CR. Okay. Y is your omega CR. X is 1. So this is the theta 1. Similarly, I can write theta 2. Theta 2 will be what? Theta 2 will be again tan inverse Y by X. Tan inverse. Now this is X is positive here. Y is also positive. So omega CR. Okay. So this is my theta 2, and the total phase difference. Okay. V output, V input is equal to, this will be cancelled, and this will come out e power or j theta 1 minus theta 2, and I'm writing it's a j phi. Okay. So let me now find what is phi. So V output is nothing. V output is your V input e power j phi, and this is the phase difference between output minus input. Okay. So in the question they have given the phase difference between V input and V output. Okay, this phi is the phase difference between V output and minus V input. Okay, so now what is phi? So phi is your theta 1 minus theta 2. Okay, so this will become minus 2 tan inverse omega CR. Okay, which is in the question given minus 90 degree. Okay. So in question they are told in phase difference between input and output. I am taking the phase difference between output and input. Okay, so this will be minus 90. This will cancel out. Okay, so this will give you omega CR. This become 45 degree pi by 4, and tan inverse 45 degree will be 1. Okay, and omega is nothing. This is a 2 pi f CR equal to 1. Now you just have to put the values, and this will give you the frequency. So the frequency will be simply 1 by 2 into 3.14. C is in picofarad and R is in kilo ohm. Okay, so if I solve this one, this is power 5, 6, and this is 12. So minus 6, so ऊपर जाएगा तो plus 6, 10 raised to power 6 upon 2 into 3.14. And if you solve this one, this will give you 159.235 kilohertz. Okay, and this is the correct answer for this question. Okay, hope you understand the question. Thank you very much.